All right, so unfortunately, I cannot take this Div 2 contest, and I haven't looked at any of the problems yet. Um, except, well, I clicked the C because usually, you know, I mean, should be able to get A and B, obviously. C, maybe I'll get it. I think I can. It's about trees, so it'd be pretty ironic if I don't get it because I do like trees. But we're gonna do this contest. I don't know how we're gonna do. I don't take contests on this account. This is more like a practice account, so I take virtual contests and do problems. Um, and yeah, so we're gonna do this virtual contest, and I can do it in the. I can sign up for the contest in the morning because I have to go somewhere in the morning. So yeah, usually I can't do the Sunday contest because I have church in the morning, and they also put contests in the morning, so it's not really the best. I That's why I don't like Sunday contests. There's They happen on Sundays quite frequently too, so it's kind of annoying. But yeah, we're just gonna put. I would be really surprised if I get A. I mean D. So I'm not gonna make a template for that. But if I have to, then that'll be nice. So problem A, or Control Z this. Parents might be talking in the background. Um, okay, problem B. Um, there might be talking like in my house, which is completely normal. Just as long as my parents are not like shouting at me, I won't pause the video here. I think my parents are actually going outside to do something, so guess that's nice. They can be silent. I don't want to take this in, so remove this. I don't want to take that because there might be a string in N, but I don't know. Hopefully we can solve these questions fast. It looks like C is a bit easier this time because 4K people solved it. So it will definitely be about speed. But yeah, I'm not sure if I can be fast. Hopefully we can be fast. Yeah, we'll see. Okay. I'm just gonna print out N to test the input. We have second threads template over here. Print out one. Why is it up? What? Oh, okay. Yeah, there we go. Okay. I might get another whiteboard because this whiteboard spazzes out. Do paper here, but I think I'm just not going to like. I think I'm just gonna type stuff like instead of drawing stuff. So CSA Academy, which is good for like graphs. Just already searched up. Yep. So the goal is to solve the first three problems, like maybe top 1,000. That would be a nice goal. I think it's a little bit ambitious for me. So, but it's not completely out of the realm if I just solve them fast. But we'll see. I don't know. Just don't like honestly. What trips me up sometimes is like sometimes I overthink the easiest questions. So I just for problem A and problem B, like okay, just let me get them out of the way, right? Like they're annoying. The reason I'm here is to see if I can solve C. So I need to get these irrelevant problems A and B and not overthink them. So yeah, hopefully that is the case. And I don't expect myself to solve D. There's 400 people. I will try, but if I what if I stuck on A through C? I don't know. Okay, that's starting, and there will be an upsolving session. I'll upsolve one problem that I didn't solve. Hopefully, we can upsolve D. and I doubt I'll be upsolving E, and I know I won't be upsolving F because only two people solved that. So let's do this. I have not seen any of the problems before. I looked at C just to see like a glance, but I have no idea of the solutions on anything. So we'll see. Okay, problem A, twin permutations. You're given a permutation of A of length n. Find any permutation B such that A1 plus B1 is less than A2 plus B2. Oh, okay. Wait, just wait. Can't you just print out 1, 2, 3, 4, 5? Isn't the first n numbers work in the permutation? Like, if you have 1, 2, 3, 4, 5, um, always works. Am I dumb? I feel like I'm gonna get a penalty on this. Such that the can you not just put the smallest one? Like, I don't understand why can't you just put the smallest one with a, so it's not as big as the because the A is fixed. I'm just gonna do this. I don't know why this isn't. Why would this not work? This is sus. Um, I'm particularly sure if this works, but you're always putting this like if A is fixed, then always put the smallest one there, so that it's not as big as the other one. I'm. Dude, I feel like this is wrong. Like I don't want to screw it. Penalty on A, it's whatever. There's no way I'm right. Oh really? Yeah, but you don't. There's no way you're just. Wait, don't debate. Always put the smallest one with the. Uh, which does it not work? What the? My God. So we want to we want to put a number here such that Wait, always put the smallest one with the smallest one. So that, what if it's like 24153, and you want to make sure that some number, uh, or I guess this is like, why is this? Oh wait, can't you just be like, you just make them 5, 4, 2, 1, 3? Just make them all equal. Does that always work? Let's say if you have like 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1. Okay, so just if for an element I, then you have n plus 1 minus I, or is it by? Just make all of them equal. Should be the solution. Pretty sure this is the solution. Um, should be just you make all of them equal. So that way 6 should work. We did solve that pretty slowly. You're given two arrays A and B, both of length n. You will merge these arrays, forming another array C length 2n. You have to find the maximum length of a subarray consisting of all equal values across all arrays C that can be obtained. A merge of two arrays result in in an array C composed by successfully taking the first element of either array and remove. Okay. Honestly, I feel like it's um like, for example, you can put one, two, whatever. It doesn't really matter. The idea is that you can put this consecutive block of ones, and then um so for example, if there's like a contiguous block of the same thing, you can put that there, and then um you notice if there's also the contiguous block starting from the same index plus that. EDP. Oops. Just don't know how you would do this yet. Um, so you can either take you have two choices. You can take the first element or the second element. Let's just say for this one, let's just try to do for this test case, right? Let's try to figure out why um, 5 is the answer, or like what we can optimize. So um, first thing we can do is we can just put like one, right? And then I remove one, and my question should be like, okay, if I remove one, then obviously I do two, and then two, 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 two. That's obvious. But what if I? How do I know that I'm going to put one though? Um, if you put two, you would remove this, then you would have to put those ones together. So removing two, for example, if you want, for example, let's say there's like a couple blocks, right? Or let's even make this more interesting. Let's say there's like ones here, and there is a bunch of twos at the end. If we want to join these two contiguous blocks, then we need to make sure that this and this are taken out. So like everything there is taken out, everything there is taken out, then we can just join them. So it should be the longest contiguous block of something. This is one, one, two. Oh, of the same thing. Okay, that should be the answer. Because you can always join so you can always join, yeah, you should always be able to join them. Just greedily take those. Should be it. You should like just keep track of the and that's the answer. I think should be the answer. Let's just implement this fast. Um, so what we'll do is we want to find max count. We'll say that answer one is one and the current is one. And then we'll iterate through a, um, and we'll say if a sub I is equal a sub I is equal to a sub I minus 1, current plus plus, else current is equal to 1, and then answer 1 equals math, answer 1 is equal to math dot max, current answer. Okay, and answer 2 should be current 2, and same idea. Probably should have not just copy paste code, but whatever. If sub I, this should be answer 1. If b sub I is equal to b sub I minus 1, then we know that the current 2 plus current 2 is 1. Answer 2, math.max, current 2, answer 2. And we should be able to just print out the sum of these. So int answer is answer 1 plus answer 2. Oh shoot. It's the longest contiguous block of 2's there are. Whoops, 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 whoops. Of the same element. Oh shoot, shoot, shoot. Oh, okay. We'll say that the actually not really. All we'll say is and then or basically what we'll do is we'll say uh I'm not gonna use this. What I'll do is that I'll go through every single integer from 0 to n, and the answer will be math. You have an answer. So equal math dot maximum of the frequency a of a sub I or of I plus g e b sub I or the I. Oops. That and the current answer. I'm very slow to this. Need to go to browse. What? This? Okay. Here we go. I feel I'm gonna be wrong for some reason. Oh my god, that was so slow. Mm. Should be right though. Just implemented that slowly. Cool. I just implemented that really slowly, damn. Uh, but it should always be okay. We're top 2,000 right now. That's not even too bad. It's always just yeah. It's pretty obvious. It's always just the longest contiguous block of each thing. Okay. Cool. Pull calc is given a list of n minus one edges, describing a tree of n vertices. Um. Okay. He decides to draw it using the following algorithm. Okay. Cool. I like trees. Draw the first vertex one. Go to step one. Step that to step zero. Step one for every edge in the input. Okay. If the edge connects an already drawn vertex U to an undrawn vertex V, you will draw the on. After checking every edge, go to step two. All the vertices are drawn. Terminate the algorithm. Let's go to step one. The number of readings ahead forms step one. Okay. Yeah, actually, to read, before taking, maybe it's okay. Test first line. The description of the first line. Let's see. So we're given first read the tree. After the first reading, the tree will look like this. So he will draw the first vertex, vertex one. Okay, and then after he does that for every edge in the input in order, if the edge connects an already drawn vertex U to an already drawn vertex V, he'll draw the edge. Uh, oh, so one connects three, one connects two. There's no wait. Oh, but then three connects four, and then one connects six. Wait, what do we? Are all the edges out there? One, two, three, four. One, two, three, four, five. Wait, four. Oh, four does not connect to five. Okay, and then the second reading, it'll be this. Okay, that's interesting. People solved it. Okay, only 271. Okay. Uh, so let's do the second test case. So we will draw vertex one. So there will just be some vertex, and we'll go through the input data. And for 5 6, we'll just say has one. There's none. Has two. No. Has three. But the answer will put 1 3. We'll add that edge. So that, and then we'll add 1 2, and then we'll add, and then 4 5 hasn't been there. Then we go to the second reading, um, and 5 6 hasn't been there, but we know 2 4 has. So 2 4. Um, and then we know 2 7 has been there. Um, 1 2 1 4 5. We've already done that. 4 5. Okay, 4 5 has also been put in. Um, so that's the second, and we still need one more reading. We need the reading of 5 6, and the tree should be complete. Is it 1 2 3 4 5 6? And there's 1 2 3 4 5 6. Okay, that takes 3. Okay, so obviously simulating through this is going to be too slow, obviously. Otherwise they wouldn't put this on here. Let's think about what we're doing here. So we're drawing vertex one, and what we can do here is how many readings. So what happened? Okay, why? First, let's think about why brute force. If the brute force can be refined to some better algorithm. So if we draw vertex one, we need to look at if we draw vertex one, then we know that its children can be into the tree. Like we know that drawing vertex one means that two can be there, three can be there, and if they're in there, then uh, that means their children can be in there. Wait, why? One connects to two. So we just find the depth of the tree. Why is that so easy? What? Why is that so easy? Just find the depth of the tree that's formed. Uh, I think it's just or wait, no, is it? You can add one, and then it will add two and three, and then uh actually, it's not the depth of the tree. What am I doing? But I think this is actually not too hard. 292. I think the idea here is that when you put in one, you know one is connected to two and three. So you can put two and three, right? So let's say one is here, then automatically two and three are there. And then two and three can add its children. Oh wait. This is not. Never mind. This is put one in the tree. Then because one is already okay. So step zero is one's here. So therefore, any vertex like 3 and 2 will automatically be drawn. But that we know that if we draw these vertex 3 and 2, then any vertex after 3 and 2, so if 2 has an edge that is if 2 is connected to another node that's after it, then they'll also be drawn into the tree. And so we need to. Okay, so we draw one, and then we'll draw three and two. The number of readings have to be within n. Hopefully I can solve this in like 10 minutes to actually get the top 1,000. I think I'm top 2,000 or something. I don't know. I definitely need to get C though. Why is this? You draw one, and we know that after we draw one, then three and two automatically connect the tree. But then after we draw three and then two, we know that this doesn't connect the tree though, because one's drawn, and then if one's drawn, uh, these nodes here are not drawn yet. So we know two and four won't work. But then I draw uh, four and seven, and you only connect four and seven if got it. I think I got the idea. Okay, so the idea here is I think what we can do is we can index these edges or index these pairs, however you want to do that. Just index the pairs, keep them as a hash map. And the idea is that what we can do is we can put one right into like a queue, and what we can do is we can connect. We know that what we do is we know from one we can connect two and three. Like we can put for one we can put basically uh all those um well what we can do is if it's one we can just put like all the its children into a queue. But we can also say like in the state, we know that two, this node has just been drawn, like the edge is 1 2. So if that's the edge, so if that's the edge, then we know that edge index has an edge index of 0 1 2 3 4 for for indexing. And so if I want to draw when I get to 2, if I want to draw 4, I can't draw 4 because I know that the edge index is less than what I want to do. Or the edge index has to be more for you to draw it. So and anytime it's more for you to draw it, um you know that you basically cannot um so you know that you cannot actually um so index so 2, you know that you can't actually draw 4 and 7 because that edge index is less, right? And or that edge index is like 2 is less than that. So the edge index is less than that, then what do we need to do? We know that if the edge index is less, well, so that means that these 1 2 they have to be on another level of the like we can't draw those nodes. Okay, so we just won't connect. Um, we just won't connect. Yeah, we won't connect it. But that's sort of a problem because then you don't connect any of its children, and obviously, but that just means it needs another reading. So if I mean, you can put the children in there, but when you connect the edge to 4, you know this edge has to be on another reading. When you connect the edge to 7, you know this has to be on another reading. But you want to obviously process the edge that you drew first. So it should just be index the edges, and then if you know that in your state, and you want to connect to your children to an edge index that's earlier than you, that requires another reading, but and then you can connect it. And anytime you from there, then it should just be the amount. Okay, I think I have a idea. So what we're gonna do is we're gonna actually just use like a hash map or um or yeah. Um I can easily make a pair class in like a minute. Yeah, I'll put class later in there. Pair integer. This is gonna edit edge index. Yeah, I don't actually think it's too. It's actually it's actually just sort of like you can you can basically simulate it. You can simulate the process by building the tree. You just need to know if it's on a different edge index. I think this is sort of just um yeah. It should just work. Edge index. So if you go in here, we'll take the n minus one edges. and we will take string tokenizer, read line, int u integer double. I'm gonna make two pairs just in case it's like bidirectional. I'm just like, I don't know. I'm just gonna do this. Uh, what I'll do is I'll say edge index dot put new pair pair uv to I, edge index dot put new pair vu to I, and basically I want to push like a state into the queue. What edge index did you come from? So I'm going to push a state into a queue, and then from two I can like connect another state. So I'll say yeah. So this is just BFS actually. In your state, I need the node, and I need just the edge index. Um, we know that we're only gonna add one if it's earlier. So in this case, this would be like just happened, or this edge index. Okay, so obviously we'll just say edge index is the minimum value, like this point. Well, do I need to keep track of like a visited? Yeah, I guess so. So say like we've sort of, so we don't revisit states. We don't want to revisit states, I guess. Like, say I visit the current state. I'm not sure if actually is not actually coming in, but I'm like, I don't. I'm pretty sure you don't need this visited array. I generally don't think so. But your answer should be one. Hold up, let me tell my parents I'm taking a contest real quick. Okay, so state current state. Current state dot edge index equals true. Taking a contest. State size is not equal to 0. State current state visit true, and then we'll say enter into 1. So then we'll say for the for the v in the tree of the current state node, if not visited, the edge index dot get new pair, um, or if not visited, or edge index dot edge index. I am pretty sure we don't have to do this. I know we don't, but I'm just gonna do it. It's whatever. New pair, new pair, uh, UV. If not visited, new pair or the current state dot node. If you not visit this, then we could put states dot add new state v1v, and we want the edge index between the connections. Basically, if you've not visited the um, this edge before, we can do that, and we haven't visited it, and then this should be fine. Like if the edge index dot get, if the index dot get the new pair, if that edge index is less than the current state dot edge index, if that's, then we know that there's another reading, because should just be answer plus plus. Basically, we know there's another reading because we have to like reconnect this. We can't go there without doing that, and maybe we'll just see if it will work, and this will just keep doing it until should be done. Um, Dang it, I won't be top 1,000. Lies. What? This is a lie? I actually think I can get this though. Um, so the currency is, I believe, just one and a minimum value, and we'll go through every child in the tree current state. This is actually just a basic BFS, if not of states. No, because the return value of that get new pair, current state dot no. This should this is a lie because wait, what do you mean? Oh, okay, I hate debugging. I feel like my logic is right though. Like, has to just be right. It just genuinely is right. Because the return value of, I mean, the first one will be one, and then you'll go to three, and we'll say if we've not seen one three. Can you before you do this nonsense, just say I'll just put false, and then can you just print out for me edge indexes of like uh new pair one three one three edge index dot get that just print that out for me. If that prints out, if that's an error, then we're screwed. I'm pretty sure it works like this. It shouldn't be an error, right? Is it? Oh, oh really? Did we not put one? It's null. Did we not? Is that not how it works? It is null. Edge index dot get new pair a1 theory. Bro, what? What? Edge index dot. Mm, I fixed the something to do with memory. That's why. So I had a backup plan. Um, I put one, and then I put three, two, and then um, I put them in the state. I put that in the state, and I put oh wait, oh wait, it might. Oh, I see. I think I've been. I think I see. I think I know. It. I don't think this should be bidirectional. I genuinely don't think it should be bidirectional. I don't think it should be bidirectional. Um. Yeah, that's just gonna make stuff weird. Nope. I'm dumb. It didn't do anything. What? Why is this? Why is this? Why is this a problem? Okay, let's just think about it like this. So we connect one, and then we'll go through its children through two. Each edge indexes, the edge indexes of the new states are obviously more than that, so that will never trigger. So connect three and two. Two has a children with one, so we've technically already visited that. So um, if not visited, edge index dot get new point current state node B. Edge index dot get. Okay, I don't think this is gonna do anything. Oh, I feel like I got this problem, bro. Okay, maybe okay. So we add one, then we add two. Here we go, and then for two, we will add two in the state. Oh, but okay. Oh, it's. I think it's because I think it's this. Um. Let's see what's wrong with this. Okay, so state one negative infinity, kernel x negative infinity. Um, this will go through the children of 3 and 2. So it'll be like if we've not visited the edge index.get the current state node 1 3, and I just do the reverse. If we just not visited them, then we can add that in the state. So we'll just do states.add new state, and we have the theory, and then the edge index of this. This is the edge index. It is 0, 1, 2, 3, and then if this edge index is less than, I feel like it should be like if it's less than the if it's less than the um Let's see like what I'm doing wrong. Actually, I need to see what I'm doing wrong. Uh, I don't know what I'm doing wrong. Why is this just not right? Maybe I'm trying to think if my logic is wrong or the implementation is wrong. I feel like it should be the parent. Like that index was this when you added two, it was two with the index of this, and those are obviously less, so they required more readings. But I feel like as if you, if it's less, you only can increment like sure we need four and we need seven, but we shouldn't. If it's less, then boom. If it's more, we don't do anything. But anything that's less will just be required in one reading. Like this with the current state that you're on, if those are less, it has to require one reading. But if it one's also less again, I mean, those will all just be drawn on one. So you can only increment. Basically, we can do all this nonsense and that'll be fine, right? And we add the state and they'll also be fine. You just add it to the queue, but since they're all connected to this current state node, um, I mean the amount that come in the pair has to be that. I feel like, but you have to have a new reading for that level of connection. It cannot be in the same thing, so it'd be. I feel like this will still be wrong. I feel like this will still be wrong. Surprise me. Dang it! Dang it! I feel like the implementation is right. It's just One should never be in here. What if there's one, then we know we're trolling. Then it's implemented, and I probably didn't implement what I wanted wrong though. I think my logic is just wrong. These are here. Yeah, it's never there. 4 7. Um, those can all be printed in the same thing. And then when you do similar to the fact that for the 4 7, why is this wrong? You you had a state, you can go there, but it just means you have to be on different readings. So like wait, is it not just I don't think you increment answer. I just think that the depth is the depth of the thinking possible one. The depth of the currency node, the adjectives dot one. I think this should be um it should be um Because I already got a penalty on this. Let me just make sure I'm doing this right. I think I should be chilling. So let's say like the depth of the tree. Then they can be the same thing. Basically, here's what I did. You can add the states like normally. You know that that requires like one. If it's coming from there, obviously requires one. If it's less than that, then it requires how this many readings plus one. If it's not, then it requires that reading, and then you just should take the maximal depth among all edge indexes. Oh my god, please work. Should be right. What? But all this is wrong. How am I wrong, bro? How? State node. This point. Honestly, for the edge indexes, just be minus one. Oh, this might be that might be the reason why. I changed. I don't see how I'm wrong. I really don't. Because I pull out the current state, and if the edge index is minimum value, then like I can't really visit the edge index, right? Whatever, it should be fine. Otherwise, we can go to the tree, and if we haven't visited, and we know there's an edge between the current state node u and v, and if we haven't visited that edge, then it's good, and we could just check uh, whatever, because we're gonna visit anyways the current state uh, dot edge index, um, but we're gonna add um, um, otherwise we add new state v, and we do edge index dot get the um, thing we're attaching it to, like the node v. It doesn't matter which way you do it. If it's 2, 3, 2, 1, we already have that. Um, and we'll say that this current state, if it's minimum, then we're coming from there, it requires one reading. Okay, so if the edge index dot get is less than L, okay, if that, then we do this. Else, if it's not the min value, then if the edge index of uh, this new state that we're gonna do, new point or whatever, if that if that is ultimately less, it ultimately requires the amount of readings of that plus one. And then we can honestly just do this. This is just redundant, but I'll keep it. If it doesn't, if it's equal if it's greater than it, then it requires the amount of reading that took. That's it. And then uh, basically, you want to say the maximum sort of depth reading. And what we could do is we know all those would be connected with one. We can do answers equal to integer min. We can go from 0 to the depth dot length, and I'll just take the maximum, and I know those are indexed from there. And then what I'll do is if the answer is some stupidly 0 or the minimum value, I'll print out 1. Otherwise, I print out the answer. I did change some stuff, but I have no idea why that doesn't work. My goodness, that was terrible. Oh my god, that's so bad. I did. Oh my god. Okay. A through C. Um. Yeah, that was pretty bad. Stupid mistakes. All right, I'm gonna take a bit of a break because obviously I don't think I'll solve D, but I'll read D. I'm gonna take a bit of a break. All right, so I'm back. Um, I'm not gonna lie, that was actually really weird. I'm probably gonna drop in the standings because I made too many penalties. Yeah, I'm just genuinely gonna drop in the standings. Yeah, I'm already dropping. I had 4 penalties on uh C. We're definitely gonna need to review um the problem. I wonder how much this guy gained actually. Um oh, so he dropped 2429. Okay, so at least I'll be top 2500. Um and he gained on a specialist. Okay, that's cool. So he gained specialist. He's a specialist. He's like a high specialist sort of, or he yeah. And he gained on that account, which means that if and we basically did the same thing. I just had one more penalty, which means that my performance was specialist type of performance. Or technically, I solved the first 2 problems earlier than him. I just completely threw the last problem. Um, so I think this is my first submission. Or my first submission was this, or was it? Yeah, I was really slow to this one. I naively did. Okay. I finally get the question, but yeah, I was sort of trolling. But looks like my performance was a specialist performance. Not an expert performance, but it's fine because I think my skill is around a specialist, so that's fine. But A through C is nice. I can explain the problems. I could read D, but I generally don't. Wait. Okay, maybe we'll do D. I'm gonna. Yeah, I'll probably take like I need to get some water and just like kind of chill. Uh, but we'll get back and we'll do more. I'm just gonna yeah. Yeah, I'm probably gonna drop around 2500 cuz yeah, I had 4 penalties on this unfortunate let me see where I am. Yeah, I'm going to be dropping the cuz 4 penalties screwed me over. I wonder okay, so I did better than this guy in general. I just genuinely did. Oh wait, no, this guy solved first two fast. But I'm trying to look for some guy who had similar. Um, this guy had like four penalties in total, and he solved the first two slower, and he solved the first three. So let's see what place he got. He's specialist. Okay, so he gained two specialists. Okay, so yeah, my performance was a specialist type of performance. Um, I think that is good. I'm definitely going to review. So we should review. Unless should I upsolve D? Um, I don't really know what to do. I'll explain the solutions, but I'm not sure if I'm going to upsolve D. I will upsolve D, but I'm not sure if I'm going to solve this in contest. It's like literally the first only 120 people. I guess we could think of it, but yeah, if you're wondering what I did in my break, I was just going on Discord, DMing some of my friends about this contest, and what I thought of it. Um, I know I'm not getting D, because one of my friends is really good and he didn't even get D. I mean, it's not good mentality. But so that's why I'm sort of like not like rushing to get D. But overall, my thoughts on the contest. I guess I'll say that after it's over. Okay, let's just try a D. The boss can count pairs. You are given two arrays A and B. Your task is to count the number of integers such that. Okay, cool. Ooh, my pair. My mom was just asking me what I was doing. I was like, I'm doing a code versus contest, right? I'm being protected already. She's fine now. Um, bro, I'm pretty triggered about C though. Like, I solved it a little. I feel like I could have solved it faster. It's yeah. We'll review. Okay, you're given two arrays A and B. Count the number of pairs such that the product of. Okay, so this seems like impossible. Yeah, probably gonna pause because my parents are talking. See, as you can hear, I'm back. My parents are not yelling. I'm actually kind of salty that I did not take this contest today because I definitely easily would. I easily would have gained easily. Um, yeah, I guess sort of yeah. I don't know. I just feel like C was sort of easier this contest because it was just a BFS. Like I've definitely seen that before. In fact, the last video is me talking about a BFS problem and in some states. So I definitely think that I was just lucky on this contest luck uh, because the C was I'm salty that I didn't actually take it, but it's fine. Because rating it if rating is not too important. So yeah, but the thing is the C was just yeah, I was lucky that the C was something that I've practiced before, like in practice. So I'm not too surprised. I took way too long on C. But as soon as I realized that, okay, yeah, yeah. But oh, my parents are talking. Hold up, I gotta, bro. Hold up, give me a second. You know what? Screw it. Cool. I don't know if I can solve the. But honestly, we should try. There's like 40 minutes. Maybe there's some trivial way. Trivial way. Such that the product of two numbers is equal to their sum. How the heck do you do this? Like, of course you know how to like friggin' brute force this. How do you do this though? Oh, are they just whoops? Are they just like? Is it just like? Hmm. You have no idea how to do this one. I might just go over solutions. I'm probably gonna like me realizing that I cannot solve D. um, um, yeah, I have no idea how to do this. I mean, this is probably some data structure question. Like you need to you need to find a J such that the product of J is equal to the sum of, or like, how do you do that? Yeah, yeah, yeah. I know. I won't. I won't. I won't. Okay. Mm-hmm. Uh, I don't even drink soda, but I guess it's for a party. I don't know. Only drink it during like parties. Yeah, baby. Okay, I'm looking at pause because, yeah, family. I'm actually thinking about how to solve this. The product of two numbers. How do you get so? Let's say for I, I'm trying. Let's say, okay, you can fix a sub I, and you can fix b sub I. Let's rewrite this. Let's rewrite this. Wait, hold up. I had to look you relocate because, dude, my sister just I had to watch Netflix. I'm like, why? And everyone's like nosy that I don't want to like talk to my family on call on YouTube, right? Uh, Boo, imagine this is literally not recording. I don't. I mean, you can obviously. I think let's. I think rewriting this might be better. I think we should relate the I's on I's and the J's on J's. Like genuinely, the. I'm so cool. Um, Dude, watch me be. I'm probably dropping the settings. There's no way I'm dropping outside the top 3,000 though. There's no way. Um, should be fine. And I know I wouldn't get hacked because I didn't use any like sauce thing. But why would I use a result sort? I've got hacked like 3 times on that, so I never use it again. Mistakes are the best teacher. Isn't this piece of IJ? So what I'm saying is that it seems like let me uh divide everything. Let me subtract a sub I minus, or I can do b sub j times a sub I, and then minus one. Subtract that. I can do b sub I, and then I could do b sub j is equal to b sub I divided by a sub I minus one. So the intuition is sort of to rewrite this. Um, Wait, why the heck is b sub I b sub j? Where's a sub I? Or a sub j, I guess. Is a sub j not here? I'm an idiot. I'm actually an idiot. This is not the expression. Here's an editorial that's out. I don't know. This contest just dropped. It might have just dropped. I don't know. Not bad. How do you do this, bro? I'm finna what? Like finna what? Finna what? How do you do this, dog? I'm taking, bro. I hope I don't tank. Oh, this guy's trolling. This guy. What was his final rank? He gained. Oh, he tanked. He tanked. Okay, so my performance was not expert level. It was only specialist level. Oh, okay, this guy tanked the. Okay, my performance was not expert level. It was not expert. It was almost. He only lost 25 rating, so it was almost expert level. I would say it's like my performance was like mid specialist level. What? How am I tanking the 2400? What? That's troll. This Raven guy. Oh, I'm showing unofficial. I should be around in the. It should be around here. What? There's no way I'm less than that. Yeah, I'm not really focusing on D because it's sort of hard. I don't know. Damn, really. But there's no way I did. No, there's no way. Okay, there's no way I'm here. There's absolutely just. I'm genuinely not. Okay, I should be chilling. I don't know why I can't see my standing though. The boss can count pairs. The boss can count pairs. The boss can count pairs. Yeah, like I should. I'm trying to try, but like the okay. Brute force is obvious, but what's making the brute force bad? What's making the brute force bad is that like if you were to fix an eye, then you know that okay, if you can fix the product. Okay, wait, no, you can't fix the product. Dude, there's literally nothing you can only fix okay. Actually it shouldn't like you know we can fix A sub I, B sub I. So we can easily fix it. So for example, the first one, let's just say we fix it both of them to be eight. Then we're looking for eight times A sub J is equal to eight plus B sub J. And wait, then we just how do I? Oh, look for an element that satisfies this a sub j. Look for an element so that satisfies this that. Oh, okay. Then we would just have to find some pair that works. How we can't obviously loop through all j. So then what do we do? I don't care if I'm cringe. Doesn't matter. Um, I don't know. I genuinely don't know how to do this. I'm not gonna admit. I'm thinking. I know. I'm trying to think seriously, but how do you find a J? So because we know this is fixed, but we have to find a J and we have to find the J in login time, right? At least login time. There's no way you can solve finding the J and O of one. Maybe you can. Maybe there's some crazy algorithm, but the reason probably will be in login time. It's just how do you find the J and login time? Like let's say you try five. Um, like, like there's like n pairs. Like you can think of the J's. There's like n pairs of J's. And so when you fix the pair, you have to find the pair that works such that um, it just works. How do you find this pair? So, for example, if you have this, like obviously you know that since you've already fixed the a sub I, can they be the they can they have to be different. So you know wait j has to be greater than this though. Oh, this is the condition. So here we know that j has to be less than or equal to n. J has to be less than or equal to n. J has to be less than or equal to n. J has to be less than or equal to n. Or it has to be somewhere here. So it's some pair here that will try maybe two, and that won't work. We'll try maybe one, that won't work. We'll try maybe seven, and that won't work. That won't give us the B sub j that we want. It's like yeah, the idea is that which pair do you is this DP or something, or is this like some weird DP? Lowkey, upsolving this is gonna be annoying. Also, like, is this some weird DP? Yeah, I don't even know. Everything seems like DP, right? I don't know. Also, you're counting the pairs. They're surprise. Okay. It's just how do you find the J log at time? Like you can't just for this J, you can't just loop through the other ones, right? And you so is there like some if you increase J? Oh, what's interesting here is that if you I think I have some idea actually. Oh, parents are talking. Wait, it should be. I think I have an idea. If you think about it like this, they're like obviously you have to upsolve this. It is a good question, I think, to upsolve though. I just don't know how to do this. I feel like this is like a general question, so it'll be really good to just upsolve. It's just like okay, that pair would give you 8 times 2 minus 8. That pair would give you 8. This is fixing. It's easy to fix a pair. You can easily fix one, which is this is the fact that it's 1 to n is sort of important. I think. What's determining what this is? Um, we know the J's should be 8 times 2, 8 times 2, 16, 8. Or I think it's just some multiple of 8. Right? Obviously, that's gonna be some multiple of 8. But this has to be This has to be within n. Has to be within n. No idea how to do this. If you're taking the product of two numbers, generally, yeah, no idea. Um, yeah, I have just no idea how to do this. So I guess I will solve. I will present solutions because I don't have any idea how to solve this. Or like I have some vague ideas, but this is sort of a new question. I'm pretty excited to actually upsolve it. There will be a review session that I'll upload during the contest. See a lot. DC was so easy this time, bro. A lot of people, 3K people solve C. Like it's not even that. Wait, it might be. That might. Okay, I don't know. Yeah, but D is obviously the difference between C and D are so is really hard. Or like for me, I can't really think of. Well, I feel like there's no point. Like I have an idea of like fixing a pair, then you have to find it, and then it's also like with an n. But like it's still sort of weird. It's still murky for me. Like I would not know how to. Yeah, genuinely would just not know how to do it. Okay, so what we'll do is go over the questions. Okay, so for the first question, we have this one was sort of it took me like oh this one was sort of weird because I first thought like so for this one this question's sort of troll. So you're given a permutation A of length n. So this is a solution for A. Find any permutation of B of length n such that this condition is true. So what this condition means is straightforward. You just like if these are the arrays, right? This. You just add this. That has to be less than adding that. Less than adding that. The key is that it doesn't have to be less. It has to be less than or equal to. At first, the way that I was thinking was that like, oh, it has to be less. If it was less, then it would be much harder. It would actually be interesting if it was less than. I feel like what's really interesting about this question is that um, they could have asked the same question had they just put the equal sign, but that would have been immediately obvious. So the solution here is that you can always form a permutation that works. Like that's like by just making the sums equal. Because if there's like five numbers, you can make the you know that like every number like is just going to work. Like for example, you can put five here, and then you can put four here, then two here, and then like one here, and then three here. And so basically, it can sum to n plus one. So the idea is just to make all of them equal. That's really just the idea. Once you think of that, it's a straightforward question. The code is also straightforward, and I'm glad I didn't get a penalty on A because it didn't actually work. First, I was like, "Is it just print out one to n?" But I was like, "There's no way," because I was thinking of making it less than. Yeah, it was. It was a first. Firstly, it was a weird thing, but yeah, you just take an A and literally just do this. That's it. Just this. Make them equal. That's it. B is, I guess, a little bit trickier. I do like B. I think B is a good question. Um, what B is B is a good question because it just feels like it feels like a 900 to 1,000, and I don't know why it took me 15 minutes to think of that. Did it really take? I'm gonna look at the film. It feels like. I feels like I was spending more time coding this question than I actually was thinking of it. I think I made a bunch of dumb mistakes. Or uh this one. So sorry, mom was asking who I was talking to. I was like, I'm making a video. Um, B was also like I did like B. Basically, and this is a common theme with problems like A and B, is they always like to make it harder than like they always make it harder than it is. Like they always make it sound harder than the problem actually is. Like for A, this looks complicated, but it really isn't. You're just doing this. And so that's a common theme with A and B is like don't think too deeply about them, right? Like just take them at face value because they will try to like just make it seem like it's hard, but it's not. Like for B, the idea is that it's just the idea is that for each number, like there's numbers from 1 to 2n, you can always merge the longest contiguous blocks of each type of number. For 2, you can always merge these four twos. This is the largest contiguous block of twos with the largest contiguous block of twos here. And why? Well, the idea is that like let's say like here's how you should actually think. Here's how you should think because you say that it says that you want to find the maximum length of the subarray consisting of equal values across all C's that should be obtained. Well, think about what your equal value should be in the array. If you want your equal value to be x, I guess this is a better way to think about it like this. I want my equal value to be x. Okay, so then what's the best answer? Like so fix your equal value. I think that will make it simpler. Like if you think of because even in the contest I didn't really I just looked at the test cases and I was like, okay, that works, right? But a better way of thinking is that um you have an equal value. The idea should be like, okay, if I fix this equal value to be x, then how do I maximize it if the equal value is fixed to be x? Well, then what you do is you just look for the longest. So, for example, I might fix it to be 2. Look for the longest contiguous block of 2's or x's in the first array, the longest contiguous block of x's or 2's in the second array, and then you can always merge those things, right? Because let's say the block is like here or something, and there's like a bunch of numbers there, a bunch of numbers there. Just like remove the numbers that are in front of it, and then for this one, let's say the longest contiguous block is here. Just remove the numbers that are. Just make sure you just put those numbers there, and you can always like do that, and you can merge it. It's pretty obvious to see. I guess the idea here is fixing the value of x. Like then you think of the solution like that. So the code here is uh, the code here is pretty easy. So you take in A, you take in B, and then you read them in. And the frequency of A is to just, I guess it's not really intuitive of why I called it. It's just to count it counts the length of the longest contiguous block. So of an element. Hold up. So it counts. So if you take in like an element inside this array, it will spit out the longest contiguous block um, of that element in the array A or array B, right? And basically, how you do that is pretty. You don't need these anymore. This was like when I was first trolling the question, because at first I was just trolling the question, but yeah, it's just going to be. This is you just check if it's equal, and then you just do this. That's how you keep track of the longest contiguous block of some element A sub I. I think that is self-explanatory. And then afterwards, just loop through all options and take the best one. Okay, C. I don't think C is genuinely not that. Like you can see, look at this, right? It's gonna be interesting when I review this because I completely trolled this problem, even though four penalties is not good. Four penalties is not good. But I was like, just I think I had an idea, but it wasn't fully established yet. Like I had an idea, but it wasn't fully established. And so then I started coding it, and then because it wasn't fully established yet, I sort of assumed a detail before I fully thought about it. So you realize that this question is like it sort of feels like BFS. This comes from like sort of just intuition from like previous problems. I have done BFS problems before, so When I read this question, I was like, it's probably BFS, and I got that idea pretty fast. The implementation was just that's a whole other story, um, which is why I'm going to review the contest. I think it's good to still like review questions even though you get them right, because there's definitely a lot of things I could take away from this question, even though I understand the solution. But the idea is actually pretty simple. So when you're like making this tree, right? Let's say I make this tree over here. Um, and you're making this tree, you know that you add the vertice one. That's the first step that you do. And then after you add, you go through these, and you're like, you obviously don't draw. There's no nodes there, but you can draw like three, and you can draw two. And then what you can do is when you draw two, can can you like why didn't you draw the idea is that like okay, I drew the edges one and two and one and three, but why didn't I not draw edges two and four? Right? That's a question. Well, the question is that the index of this edge is less than the index of that edge. So you cannot draw it. That's why. Um, so that's sort of and then sort of this motivates like a BFS solution. In this question, you can think of this in terms of states. Think of it as like if I'm drawing a node. Think about okay, let's say I draw an edge, right? I draw an edge. Think of it as okay, what is my edge in my state? What is my edge index? Right? If I know my edge index and what is the current amount of readings, right? The current amount of readings, I should have made this clear in my code. The current amount of readings is basically just the depth, is like the max, is the height of the tree, actually. So you're going to be forming a tree, but it's sort of like the height of the tree in a sense. But basically, just think of the depth that I called it, just the current amount of readings, right? Because in a state, you know, you have the index of your edge, right? And you have the current node, like for example, if this is like 1 2, then this state would be the current node is 2, the edge index is the index of the 1 2, the 1 2 edge, which I clearly do over here. And I use point because the first time I used pair and I realized that memory problems, right? And uh so that's what you do. And another thing you can keep in your state, which I actually didn't do, that I should have added it into this, is just the current amount of readings. Reading amount. So this is actually another thing. It's just the reading amount. The reading amount, you could have I could have done that, but instead of doing that, I just kept it in an array. But you could definitely, it would definitely, my code would definitely make more sense if I just put that in the state. It would be like cleaner for sure. But yeah, you keep track of the reading amount. So this looks really complicated here, and I'm going to look for better ways to implement this for sure. This looks very complicated, but the idea is that I don't think you even need this visited array. I genuinely don't think you do, but I was just getting paranoid. um, Again, I'm going to review that, but the idea here is honestly, if you're visiting a state, don't worry about these if statements. It's just like if the edge index, right? Let's say you're visiting a state and now you want to go through the next states, right? So you have the node of your state, you go through its children, and you want to connect edges to make future states. So the idea is that how many readings will the future state take? How many readings will the future state take? Well, if the future state, if its index is earlier on than this one, then it's going to have to take one more reading, because then you would have to draw this and then you have to come back and do that. It will have to take one more reading, right? But if it's later on, then it will take the same amount of readings, which is over there. And so then the idea is that the answer should just be, since you can always find like how many readings a state takes, the answer is that you just find what is the highest for all the states, or the state indices, which is like the edge index for all those indices. Just calculate the maximal amount of readings that one state takes, and those all the states will finish within that, and then that's your answer. So it is a pretty good question, because it's just BFS and states. It's not too complicated. And yeah, that is it. Um, D seems like a good question. D, I honestly don't know. I think we just need to work on speed. I think the knowledge is definitely there though. It will my performance is definitely going to be top 2500, 2400 or something like that. Um, yeah, so that's basically all the solutions. I overall thought this was not just because I solved A through C, which is I would like content with that. My performance can definitely be better, but I thought this was a good contest. I liked A because it was like okay, it's sort of this. It feels like a code versus A. Like these 800s like are trivial, right? Because the code looks like this, but it's so easy to overthink this. Like if you don't pay attention to the fact that they can be equal, then this question becomes like much harder. I don't know how you would solve it if they didn't. Like, I would actually be interested in the case if you can make them equal. So that's good. That's something good we can do in the review session. But yeah, this 800 it felt like a code versus A. It's very easy to overthink and misread. So you should always read this properly and make sure you actually understand every detail. Like don't just overlook this equal sign. Like it can be equal to it. And once that you have that, it's fine. So implementation was fine. And then B, I did like B too, because B was like you think of it greedily. It's sort of like you fix information that you don't really know. You fix the equal value, and then if you fix the equal value, think of it greedily. Think of like let me just take the longest contiguous blocks and let me just like merge them. So you guys sort of think greedily, and you realize that does that always work? It does. So it's sort of like you think greedily, which is intuitive, then it works. And then C was again just a good question because anyways these are cringe penalties. This I shouldn't have gotten a penalty on this one though because I the reason why I got a penalty is because I still had this increment once thing. So sort of troll, but I feel like this was just a good question because you look at this and you're like, oh, how many readings does it take, right? But you could say how many readings a state takes, and then when you're transitioning to another state, well, you know how many readings that state will take. It just depends on the previous state, and then you can find like the max amount of like readings. You know what I'm saying? So it's more like you think of them. So you think of this problem more of states. I guess like something like you can think of as like the number of readings is defined as sort of for these algorithm problems. It's like you can simulate them. Like you can always like simulate this and actually like because you're technically like actually building the tree. It's just that like when you simulate the process, you're simulating it efficiently, if that makes sense. And so that's a common theme that I've seen before in Codeforces questions. And my overall opinion on my performance is I would say it's generally good performance. I've done worse in Div 3s than I've done in this Div 2 contest on virtual. So I would say that's nice. It was a tree question. I do like trees. Um, I um, I think my predictions is that this will probably be an 800. This will be 1,000. I think a 900 or 1,000. Definitely not more than 1,000. This would be like maybe a 1,500 or a 1,500 or 1,600 rated problem. And then D, I think it's going to be like a 1,900, 2,000 from the amount of reads. And then I don't know. E and F, I didn't even bother looking at them. So yeah, that is the solution. I'm going to wait until this 1 minute is over. Just gonna wait and then I'm gonna Upsolve. I think in another video I'll be reviewing what I could have done better on each question. Because I think after you take a virtual contest, you have to sort of like review what you did, and then also I'll be Upsolving D. And once I do that, I will probably like relax and chill, and then solve more problems after I chill, and probably be the video or like I won't film myself chilling and like doing more problems. But yeah, I want to take this virtual contest because the last virtual Div 2 contest I took was actually kind of unfortunate because I stopped doing the contest early because I had to leave, and I also did pretty bad because I overthought A, and I actually just realized that just don't overthink A's, and yeah, that's why you review your contests. Um, yep. I'm just interested to see my standing. Um, um, and yeah, so it ends in 20 seconds. Uh, okay. Okay. Top 2500 performance. How much did that guy get? Cool. Okay, that will be the end of the video. Nice. So my goal was actually top 1,000, but we got top 2,500. So whatever that is, it is what it is. But I think, anyways, it was an okay performance.